All right, this will be chapter 5. I'm not going to do the exact problems in the review packet for you, but what I will do is I'll talk you through a handful of them, and I'll show examples similar to them, and if you can just kind of replicate what I do to your specific problem, then you should be just fine. So I'm going to start with number 2. So number 2, which of the following statements is true? Now this one I will actually go ahead and work out and kind of let you know, because it does require kind of like an understanding. So which of the following statements is true? Well, first you need to know that a complex number is a plus bi. A is a real part, a real number, and then b is the imaginary part. Okay. So for example, 3 plus 2i is a complex number. 3 is the real part because 3 is a real number. And then 2i is the imaginary part because, of course, I is the imaginary number. So let's talk about each of these problems or each of these answer choices. Every real number, this is A, every real number is a complex number with an imaginary part of -1. Well, every real number, so, real numbers like we've talked about are real numbers. Like 5 is a real number, and 3, as mentioned up here, is a real number, and -9 is a real number. Like, just regular numbers, right? So every real number, every single one of these, is a complex number with an imaginary part of -1. So that's saying that 5 is the same thing as 5 plus -1i, which I'll rewrite as just minus I, because -1 plus -1i is the same thing as just minus I. So is that true? Is 5 really the same thing as 5 minus I? And no, it's not, because you have an imaginary part there. It's a complex number. It's an imaginary number. That's not true. 5 wouldn't be the same. And just like all these other, 3 would not be the same as 3 minus I. That's just not true. So what about B? B says every real number is a complex number with an imaginary part of 0. So every real number, like 5, is the same thing as the complex number, but with an imaginary part of 0. So 5 is the same thing as 5 plus 0i, and 3 is the same thing as 3 plus 0i, and -9 is the same as -9 plus 0i. Now this is true, actually. This is the right answer, because if you have 0 imaginary part, then the imaginary part is 0 in a sense. So it's not there. There is no imaginary part. So 5 is the same thing as 5 plus 0i. This is a complex number. The imaginary part is 0, and it's the exact same thing as the real number 5. And that's what B is stating. All right, so C is wrong. C says every real number is a complex number with an imaginary part of 1. That's basically saying the same thing that A said, that 5 is the same as 5 plus I, and 3 is the same as 3 plus I, 1i, if you want to think of it that way. And that's just wrong. And then D is sort of the opposite way around. Every complex number is a real number with an imaginary part of 1. And that's not true, because every complex number doesn't have to have an imaginary part of 1. Any complex number can have an imaginary part of anything. It doesn't have to just be 1i. It's basically saying that complex numbers are only numbers that have 1i in it. Like 5 plus i is a complex number, but 5 plus 2i isn't, because it doesn't have the 1. And that's just not true. So B is the correct answer for that one. Number 3, simple one, a complex conjugate. I won't do that example for you, but I'll tell you what a complex conjugate is. So if I have a complex number like -9 plus 3i. So again, you got the real part, you got the imaginary part. The complex conjugate of this is -9 minus 3i. In a sense, all you're doing is let me turn that down, is you're changing the imaginary part sign. So you keep the real part, -9 is still -9. We're not changing that to +9. We keep that the same. But whatever the imaginary part is, we change the sign. So for example, 4 minus 9i, its complex conjugate is 4 plus 9i, because we changed the imaginary part. Sometimes they try to trick you and they write these backwards. So for example, you might have -3i minus 9, and its complex conjugate would be 3i minus 9. So again, the real part, which is -9, doesn't change. It's not supposed to change. It's only the imaginary sign, the imaginary part, that changes. And because this is sort of written backwards, it's easy to get that confused and mixed up. But just be aware of that. It's only the imaginary part's sign that changes. Okay, so number 4. Number 4 is just a matter of combining like terms. So let me make an example that's similar to it. Let's say I've got 4 minus 12i minus, and I'm going to keep the negatives exactly like the one in your problem. Negative, well, you got 3. So we'll say negative 7 minus 10i. So this is just combining like terms, but you do have to be very careful with all these minus signs. So like terms, I got 4 and minus 7, and I can combine them, but you got to be careful because it's 4 minus this minus sign, negative 7. So you've got 4 minus, and then you're subtracting a negative 7. So 4 minus negative 7. So that's really 4 plus 7, which becomes 11. And then you can combine the imaginary parts, but again, be careful with all these negatives. So negative 12i minus negative 10i. So negative 12i minus, then negative 10. So you've got 2 minuses to look out for, minus negative 10i. So again, that's really like a plus 10i. So that's going to be negative 10. Negative 12 plus 10 is negative 2. So that'll be negative 2i. So that would be the answer. And you would do something similar to that with number 4. I'm going to skip number 5. We're going to go to number 6. Number 6 is a doozy. So number 6, we got a division problem. So I'm going to make one up. I'm going to say I've got 3 minus 5i divided by negative 2 plus 3i. Now, we never wrote it this way in class. This can be written the exact same thing as 3 minus 5i on top, and on bottom have negative 2 plus 3i. So this is the same thing as this, except it's written vertically rather than horizontally. So I'm going to erase what was up here, and I'm just going to stick with my new version of it. Now, when we divide these, we don't actually divide. It's kind of a trick. We're actually going to multiply this by the complex conjugate of the denominator. So you have to look at your denominator and find its complex conjugate. So in this case, my complex conjugate would be negative 2 minus 3i. And I'm going to put that on both top and bottom. Okay? And your problem will be the exact same. Now, since I'm multiplying, I just multiply straight across. So I'm gonna have to FOIL the top together, and I'll have to FOIL the bottom together. So let's start with the top. So foiling 3 times negative 2 will become negative 6. 3 times negative 3i will become negative 9i. Negative 5i times negative 2 will become a positive 10i. And then negative 5i times negative 3i will become a positive 15i squared. All right, let's go ahead and FOIL the bottom. So negative 2 times negative 2 will be positive 4. Negative 2 times negative 3i will be a positive 6i. 3i times negative 2 will be negative 6i. And 3i times negative 3i will be a negative 9i squared. So a couple things to do. I squared, you have to remember, is negative 1. So here, this is really 15 times negative 1. So on top, that's really just a negative 15, because 15 times negative 1 is just going to be a negative 15. There's no more I, because you're converting the I squared into a negative 1 and then multiplying it with that number. So in the bottom, you have negative 9 times I squared. So again, that's negative 9 times negative 1. And when you do that, that turns negative 9 into positive 9. Okay, so now you've got a few like terms. You can combine the real, I thought I changed the color, hold on. Apparently not. Okay, on top you have the real number, negative 6 minus 15. We can combine that. Negative 6 minus 15 is negative 21. And we also have the imaginary part, negative 9i plus 10i, which is negative, no, that's positive 1i. So plus 1i. So, or plus I. You can just think of it as plus I. Okay. And on bottom, we have negative 4 plus 9. Negative 4 plus 9 is 5. So we're going to write 5 there. And then the positive 6i minus 6i will cancel out. So I don't have that. It's just 5 on the bottom. And so that's my answer. I could try to reduce my fraction, but I don't think I can in this case. My answer is going to be negative 21 over 5 plus I over 5. Or 1I over 5. You might say 1/5 I. Same thing. I know in the problem you guys have, you're going to have to simplify fractions. So, for example, if this ended up being negative 22 plus 4I over 2, or let's make it a little more difficult. Let's say it was 6, and then it was over 4. This could be reduced to negative 11 over 2, and then the other side can be reduced to 3I over 2. Yeah, so there are some things you would reduce, but the big thing to take away from this is the foiling. Skipping number 7, let's talk about number 8. Number 8 is pretty simple. What's the imaginary part of the complex number? I'll let you guys figure that out. We've already kind of talked about that. Number 9, there's actually a typo in number 9. I will say number 9, when it says 7 minus the square root of 81, it's supposed to be 7 minus the square root of negative 81. Okay, so they forgot the negative when they made this booklet. But let me do a problem that's similar to yours. So let's say I've got 3 plus square root of negative 64. And I'm doing plus 8 minus the square root of negative 25. Well, I'm going to go ahead and simplify these radicals. So square root of negative 64 is 8I, because the square root of 64 is 8, but the negative in there is what becomes the I, the imaginary part. So that becomes 8I, and then we're going to add 8 minus, okay, so this one, the square root of negative 25, similar. Square root of 25 is 5, but the negative on the inside makes it 5I. So now it's just combining like terms. 3 plus 8 is 11, and 8 minus 5, or 8I minus 5I is 3I, so that'd be 11 plus 3I. So simplify the radicals, and then just combine like terms. Number 10, I think we skip. Number 11. So you got square root of, and I'm going to make up my own number here. I'm going to say the square root of, I'll say negative 8. And then I'll say times square root of, we'll put this in parentheses, square root of negative 2. That's similar to yours, but it's still a different problem. Minus, we'll say the square root of 4. So it's similar to your problem, but it's going to be a little different. So it's weirdly written, but this is multiplication, and it's just really distributing. We're going to have to distribute this square root of negative 8 to both terms. So it's really just multiplying what's inside the radical. Notice I've got negative 8 and negative 2. Well, I'm multiplying them together, and they're both inside the radical. Negative 8 times negative 2 is 16. So when I multiply square root of negative 8 times square root of negative 2, I just get the square root of a positive 16, since the negatives multiply together to make a positive. And now I want to do the other part of this, the negative 8 and the 4. So I still have that minus sign. This minus sign here is still going to be here between these terms. But the square root of negative 8 and square root of 4. So the square root of 4 is 32, or not the square root of 4. The square root of 4 is 2, actually. Hold on. Actually, let's make this a different number. Let's say that this is 3. Actually, it's very similar to your problem now, but it's still a little bit different. I'm going to say it's 3 because I saw something I didn't want to have. So negative 8 times 3 is negative 24. So that would be the square root of negative 24. So that's just multiplying it together. Really, since everything's inside the radical, both of these are inside radicals. And it was just regular multiplication. Negative 8 times negative 2 and negative 8 times 3. The thing is, we can simplify. Square root of 16 in my case is 4. So that's just plain and simple 4. Now this is a little different. Now I've got the negative on the inside, so I know I have an I as part of this. Let's put this minus sign down there. So I know I have an I, but the square root of 24 is not a perfect square. And to simplify this, I have to think of a perfect square that goes into 24. So, 4, 9, shouldn't put a line there, 4, 9, 16, 25. can I divide 24 by any of these numbers? I can't divide it by 25, can't divide it by 16, can't divide it by 9, but I can divide it by 4. So 4 times 6, right? The square root of 24 is the same as the square root of 4 times 6. Breaking both of those up, I've got square root of 4 separated from the square root of 6. The square root of 4 is a perfect square. I chose that up here for that particular reason. That becomes 2, and that stays square root of 6. And that's going to be joined with the I because the I was part of that negative. So together, it's 2I square root of 6 as that result. You could say 2 square root of 6 and then I at the end, but it kind of doesn't look right because sometimes people get confused whether that I is inside the radical or not. So I put the I up with the 2 in front of the radical so that it wouldn't be that confusing. All right. Number 12 is very similar. You're just going to have to FOIL. So if you can FOIL, you should be okay. I do recommend, though, that you simplify the radical. So simplify the square root of -6. I'll go ahead and do this one partially with you. This simplifies to, the negative part is going to become the I. So the square root of -1 will just become the I. But the 6 can't be broken down. So that's simply just going to be I square root of 6. So use that in the problem as you're FOILing. And also go ahead and convert the square root of -100. Square root of -100 is 10I. So use that in the problem as well. And if you do that and you FOIL, you should be able to work it out. All right, that's going to be it for the chapter 5. I'll see you guys in the chapter 6 video. Later.